All right, next we are going to talk about what we call bomb calorimetry. And despite what it may sound like, nothing blows up, unfortunately. A bomb calorimeter is just a large steel vessel with really thick walls that can withstand high pressure changes, and that's why they call it a bomb calorimeter. Okay, it's used for combustion reactions. And the key to this is they are all at constant volume. And because they are at constant volume, I'll show you in a second, they measure change in internal energy, delta E. And the reason is, if you look at the equation for delta E, it is equal to Q plus W. And then remember what W is. W is equal to negative P delta V. So if we make that substitution in there for W, then delta E is equal to Q plus, minus P delta V. Delta V, there we go. Well, if we're at constant volume, guess what? This term at constant volume, that is V final is equal to V initial, then that term goes to 0. Delta V is equal to 0. So the reason we measure internal energy is because calorimetry measures heat flow, and Q is heat, and we give this a Q sub V. Okay, that means it's heat at constant volume. Now, how do we measure that Q sub V? Well, we use another simple equation. Q calorimeter is equal to capital C calorimeter times delta T. Okay, and what are all those things mean? Q, the calorimeter, is just heat flow in joules. C, that's the heat capacity. Of the calorimeter. In joules per degree Celsius. And then delta T, that's the same thing as always, T final minus T initial, and we have units of joules. Okay, and joules. It's temperature, degrees Celsius, sorry. Okay, so let's do a quick problem. Oh, I had scratched the word if out on my paper and can't read. 0.5 moles of a substance is combusted. That just means reacted with air, gives off heat, in a bomb calorimeter. Okay, we're going to be doing other types of calorimetry. The lab this week is different types of calorimetry, and C-cal is equal to 5.2 kilojoules per degree Celsius. And it's fine that it's kilojoules and not joules. It doesn't really matter. And the temp goes from 21.2 degrees Celsius to 24.3 degrees Celsius. What is delta E of that reaction in kilojoules per mole. Okay, pretty straightforward problem. We just have half a mole of a substance. We know the calorimetry constant, as it's sometimes called, it's just the heat capacity of the calorimeter. We have two temperatures, and here's what we need to find: delta E in units of kilojoules per mole. So we're just going to take that equation we had up above. Qcal is equal to Ccal times delta T. Okay, and that is simply equal to 5.2 kilojoules per degree Celsius times 24.3 degrees Celsius minus 21.2 degrees Celsius. And we come out with 16.6 kilojoules. But that's not our answer because the problem asked for kilojoules per mole. And notice we were given a half a mole of substance. So this is the amount of heat that is released, or energy change, I should say. That's the energy change for half a mole of substance. So what is it for a full mole? Well, that's pretty easy. Delta E of the reaction is equal to 16.6 kilojoules, and now we just put that over how many moles we had. So that gives us 33 kilojoules per mole. And that's the right number, 6 folks. And that's it. Just remember, bomb calorimetry, constant volume, measures internal energy.